Welcome back to the deep dive. Today we're doing something a little different.
A lot different, I'd say.
Yeah. Usually, we're in the safe harbor of peer-reviewed science, stuff that's been through the whole academic process.
Johnson approved.
Exactly. But today, we are looking at a wager, a huge, high-stakes bet against the standard model of cosmology.
It's a fascinating scenario.
Mm-hmm.
We're looking at a set of documents from an independent researcher, H3O Labs. And this isn't some minor tweak.
Yeah.
This is someone walking up to the cosmology roulette table, putting all their chips on one number, and saying, spin it.
And that roulette wheel is the data coming from the James Webb Space Telescope and the Dark Energy Survey, late 2026, 2027.
Precisely. The core idea of this S-Matter framework, specifically Revision 18.0, is that the current crisis in cosmology,
The Hubble tension, the impossible galaxies.
all of it. The crisis isn't because our instruments are wrong. It's because our geometry is wrong. Our fundamental assumption about space is flawed.
And that's the hook for me. Not that we need a better lens, but that we're looking at the wrong movie entirely. So let me get into the core of it. This S-Matter idea. The source material calls our universe a projection. That sounds like science fiction, but the math they're using it's very specific. So walk me through that.
Okay, so the best way to get into this, I think the author gives us a really good entry point with the flatland analogy.
Oh, right. The classic.
Yeah, but with a crucial twist. So imagine you live on a two-dimensional movie screen. You've got length, you've got width, but absolutely no depth.
Okay, I'm a stick figure. I can move left, right, up, down. That's my whole world.
Exactly. Now imagine a complex 3D object, say a rotating crystal, is hovering behind your screen, and a light is casting its shadow onto your world.
So on my screen, I'm just seeing a 2D shape that's changing. It's growing, shrinking, twisting.
To you, it looks like it's alive, it's evolving. You, as a 2D physicist, would invent laws to explain it. You'd call it force X or particle Y. You'd invent the idea of time to measure the sequence of changes.
But the real object isn't actually changing at all.
It's just rotating, timelessly. The movement you see is just an artifact of the projection.
So our universe, with 3 dimensions of space and 1 of time, that's the shadow.
That's the argument. We're a 4D projection of a 5D substrate, which they call S-Matter. And that substrate is reconfiguring in a state that's completely timeless.
Okay, let's just stay there for a second, because the philosophical side of this is huge. If we're a projection, what is time?
It's not a river we travel down. In this model, time is a refresh rate.
Like a computer monitor.
Exactly like a computer monitor. The screen updates 60 times a second. The pixels aren't traveling from the last frame to this one. The whole image is just rewritten.
So yesterday isn't a place I can go back to. It was just a previous configuration of the screen that got overridden.
Which leads to one of the biggest claims in the entire framework. Time travel is physically impossible, not just hard. Impossible.
Because there's no there.
No there. You can't visit a previous shadow because the object casting it is already turned. That configuration is gone forever. Entropy isn't a journey. It's just the next frame loading.
Wow. That solves a lot of paradoxes right there. No killing your own grandfather if you can't even get back to the right frame.
It simplifies things, yeah. But this isn't just philosophy. The author applies this concept directly to solve the JWST paradox.
The impossible galaxies.
Right.
Yeah, I see these headlines all the time. Webb is looking back to the very dawn of the universe and seeing these huge, mature galaxies.
They're like adults in a nursery. Our standard model says galaxies grow up slowly, little gas clouds merge, they get bigger over billions of years.
It's a slow cook recipe.
And we're seeing these fully cooked meals right after the oven was turned on. The standard model is, let's say, struggling to explain it.
But S-Matter has an answer, informational projection.
Right. It says these galaxies didn't grow in our timeline, not in the way we think.
They were just born big.
In a sense, yeah. They were projected into our reality already complex. Think of a video game. When you load a new level, does the game engine build the castle brick by brick?
No, it just pops into existence. The whole thing is rendered at once.
Exactly. The time it took to design the castle was in the code, in the substrate, not in your gameplay time. These galaxies had their formation time in the 5D substrate, not our 4D history.
So we're seeing a complex render, not something that grew impossibly fast.
Correct. The author actually reached out to Gabriel Brammer at the Cosmic Dawn Center. He's a major figure in this field, suggesting they use metric latency as a prior in their models.
Metric latency. Okay, that term feels like the bridge. Because if the universe has a refresh rate, it must have a lag.
And that lag is where this theory takes on dark matter directly.
All right, let's unpack this, because the standard picture of dark matter is that it's a particle, right? Some invisible stuff with gravity.
Some kind of whim for axion, yeah.
Yeah.
And the textbook proof for it is the bullet cluster.
Right. Remind us what that is.
The bullet cluster is this. It's a colossal collision. Two galaxy clusters smashed into each other at incredible speed.
A cosmic car crash.
A huge one.
Yeah.
And what happened was the visible matter, the gas crashed and slowed down because of friction, but the gravitational lensing, the gravity part, it kept going.
So you had the visible stuff in the middle and these two blobs of gravity way out on either side, and the conclusion was?
There must be invisible particles, dark matter, that don't interact, just flew right through, carrying the gravity with them.
The smoking gun.
It is the smoking gun. But S matter says, you don't need particles. What you're seeing is metric lag.
Back to the refresh rate.
It all comes back to that.
Yeah.
You know, on an old, slow computer, when you drag the mouse really fast and you see that trail of cursors behind it?
Oh, I know that well. The ghost trail.
That's what this is.
Come on.
Gravity is the shadow. The source object in the 5D substrate is moving at an insane speed like 4,700 kilometers a second. The screen of our universe. It takes a moment to update the curvature.
So the gravity isn't ahead of the gas because of particles. It's trailing behind the real source because space-time is slow to render.
You've got it. It's not dark matter. It's processing latency.
That just flips the entire picture on its head. That is a really cool idea.
And here's the key. They put a number on it. This is in revision 18.0. They derive a specific constant for this refresh rate. They call it talp.
Yeah, I've got it here. It's talp approx 3.01 times 10⁶ seconds.
Which works out to about 950 million years.
Okay, wait. A refresh rate of almost 1 billion years? That sounds huge. Why doesn't my coffee cup lag when I move it?
Well, because your coffee cup isn't the mass of 100 trillion suns and it's not moving at a fraction of the speed of light. This is a metric effect. It scales. For us, it's instantaneous. But for a galaxy cluster in a high-velocity collision, that lag becomes measurable.
And this leads to a testable prediction.
The big one, the lag tail. This is what could make or break the theory. The author is challenging the dark energy survey. Look at your gravitational shear maps for these high-speed mergers. If dark matter is just a big cloud of particles, the gravity map should be pretty symmetrical, right? A cloud is a cloud. But it's a lag.
It should be smeared out, stretched, like a comet tail.
Exactly. And asymmetry, elongated in the direction opposite to the movement. If they find that tail, particle dark matter has a huge problem.
And if it's perfectly symmetrical, S matter is dead. Wow, that is a clear, falsifiable test.
That's what makes it science.
So we've replaced dark matter with a rendering delay. What about the other mystery? Dark energy, the thing pushing the universe apart.
Right, the cosmological constant, lambda, which is basically just a number we stick in Einstein's equations to make them fit what we see. We don't really know what it is.
It's a fudge factor, kind of.
A very successful one, but yes. S matter replaces it with a dynamic process called hydraulic balance.
Hydraulic, like water pressure.
Sort of. The idea is that the universe is expanding because energy is constantly flowing from the 5D substrate into our 4D manifold.
So it's being inflated, like a balloon.
More like a leaky faucet. It's pressure equalization. Energy is dripping from the high-pressure substrate into our low-pressure universe. Again, they give us a hard number. The hydraulic inflow rate, gamma.
Let's see. Gamma approx 4.3 times 10^44 kilograms per cubic meter per second.
It's an unbelievably tiny number.
You'd never notice it.
Not in this room, no.
Yeah.
But when you multiply that tiny drip by the staggering volume of the entire universe, it's enough pressure to drive cosmic expansion.
So the prediction is that dark energy isn't a constant number.
Exactly. As our surveys get more precise, the data should show that it's not a static value. It's a dynamic flow, and it should converge right on that number for gamma.
I just love how specific this is. This is not hand-waving. These are hard numbers.
Which is the whole strategy. This pre-discovery record, the author is planting digital flags in the ground.
Let's talk about that, because the meta-narrative here is fascinating. They talk about the catch-22 of academic publishing.
Oh, it's a huge problem. To get a paper onto ArcSIF, the main physics server, you need an endorsement from someone who's already established.
But to get that endorsement, you need to have already published. So if you're an independent, you're just locked out.
You're shouting into the void. So ACE3O Collabs is using their website as a public, time-stamped laboratory record. They're posting the predictions now, before the data comes in.
Calling their shot.
Precisely. They've even sent formal records of their work to people like Avi Loeb at Harvard and Brian Greene at Columbia.
Just to get it on the record.
It's smart. It's due diligence. Even if nobody replies, there's a timestamp trail. The math was sent before the discovery.
And one of those digital flags, one of those predictions, feels like it could be tested almost immediately. The void hydrogen floor.
I agree. This is the one I'd be watching over the next year.
So the standard model says the giant voids in space, the empty bits between galaxy filaments are, well, empty.
It's close to a true vacuum as you can get. Almost zero density.
But S-Matter says no. Because of that hydraulic inflow, that constant drip of energy from 5D.
You can never get to zero. There has to be a minimum density, a floor.
And the number they predict is SEI approx 2.00 times 10 to the 7 atoms per cubic centimeter.
Which is, what, a couple hundred times denser than what standard theory would expect to find there? And they're calling out radio astronomers directly?
Saying, check your noise.
Exactly. Because think about it. If your model tells you there should be nothing there, and your telescope picks up a faint, uniform hum, what do?
You assume it's background static, an error in the instrument. You filter it out.
You scrub the data. The author is saying don't scrub it. That faint hum is real. That's the sound of the substrate.
That gives me chills. The idea that evidence for a 5D reality might have been sitting in the deleted items folder of astronomers for decades.
It's entirely possible. And they actually cite a recent paper from January 2026 by Heinz et al. That found these huge webs of cold, neutral gas way back at redshift 5.4.
Which supports their idea of a cold start universe instead of a hot Big Bang.
Right. The standard model is hot Big Bang, then cool down. This S-Matter model is inverted. It's a cold start, and then things heat up through gravity. Finding that much cold gas so early is a big point in their favor.
So let's just recap the big bets, the digital flags that Revision 18.0 has planted.
Okay. Number 1, the inflow rate, gamma, which replaces dark energy. Number 2, the packing limit, phi, which is a geometric constant we didn't get deep into, but it's why the model needs 5D. 3, the metric lag, taup, the refresh rate that replaces dark matter.
And 4, the void hydrogen floor, the minimum density of empty space.
Those are the 4 big ones.
If the new data from JWST and DES even comes close to matching just one of those numbers,
then this changes everything. We're not just talking about finding a new particle. We'd be talking about hard evidence that our entire reality is a projection.
it would be a paradigm shift on the level of Copernicus.
Absolutely. It changes what space is, what time is. It even changes what we are.
So what's the takeaway for you, the listener? Why should you care about this bet?
I think. Because it's a powerful reminder that science isn't the set of facts in a textbook. It's a messy, living process. And right now, the data from our best instruments is screaming that the textbook is wrong about something fundamental.
And maybe the answer isn't going to come from the committee. Maybe it comes from someone just looking at the puzzle pieces a different way.
And realizing it's a 5D puzzle we've been trying to force into a 4D box.
I want to leave everyone with a final thought experiment from the source material. We talked about being a shadow. If our universe is just a shadow and the object casting it exists outside of time,
Then every single moment of your life, it's just one frame, one refresh of a geometry that is already whole and complete.
and if entropy, if death, is just the system reconfiguring for the next frame,
Does the shadow die? Yes. But does the source object? The information is just rearranged. It implies a kind of physical continuity that's hard to distinguish from the idea of something eternal.
a reality we can never see directly, but whose reflection we are living inside. That is a heavy thought to end on.
It is. A lot to chew on.
We will be watching the 2026 and 2027 data with a whole new perspective. If you see a headline about a lag tail or a hydrogen floor, you'll know what it might really mean. Thanks for diving in with us.
My pleasure.
See you in the substrate.
Or at least in the next refresh.